Okay, second part of this video here, I realized at the second part of this problem right here, I realized at the end of the last video that I forgot to tell you what I wanted to know. So I want to find Q of t, just like we did in the first example, but I'm also asking you a question that's going to make you think through all the parts that we have here. And that is, what's the concentration of the solution when the volume is 150 liters? So I'd like you to think about that for a moment. I've got this guy here, 5 liters coming in every minute, 4 leaving. We start with 50 liters. So how long is it going to take to get to 150? Because we're going to need to plug in a t value to this q to figure all this stuff out, right? So I'd like you to think about that for a little. I'm not going to jump into it yet, but think about that, and then also think big picture. All right, 5 coming in every minute, 8 liters. We start, or 8 grams per liter. We start with 50. And then there's only 1 gram per liter. So the concentration is a lot lower than the 8 that's coming in. But we got a lot, we got more coming in than going out. Maybe a good amount of time is going to go by. What would make sense for the concentration of this thing after, a generous amount of time's gone by? So anyway, we will talk about that in a little bit. First thing I want to do is solve this differential equation. So it's normalized. So let's calculate our mu. Mu is e to the integral. I'm going to write my 4 out front. I typically like to get those, get rid of whatever I have up there so it's easier to integrate. 4 times the integral of 1 over 50 plus t dt. Well, that is e to the integral of, come on, man. It is e to the 4 times, what's that integrate to? ln. And I'm going to write 50 plus t. Now, this is where I can be, I can break some rules. Usually I would want absolute values there. In this case, we don't really care, and we're not really applying this solution to time before 0, right? And you could even say, all right, well, maybe we go back to time equals negative 50, but for our purposes, we're just looking at positive time. So that ln is always going to be positive. So I ain't got to worry about negative numbers. Anyway, small details. Plug it, e to the ln of 50 plus t to the 4th power, which the e and the ln cancel, and I get 50 plus t to the 4th power. Now, this is where, this mu, is kind of magical, right? It does a lot. Having this formula does a lot of work for us. If you look at this and you're like, how would I integrate? What do I do? How do I make product roll? It's really hard to piece it together. Watch. Once we get this, it's like, oh, sweet. If I multiply that by everything, I get 50 plus t to the 4th power times q prime plus, all right, what happens when I multiply this by that? Well, I've got 50 plus t to the 4th. I got a 50 plus t in the denominator. That means the 4 is still going to be there, open, 50 plus t, it's cubed, times q, I was about to say q prime, equals, and then I'll write the whole thing, 40 times 50 plus t to the 4th power. Look at that. This thing right here, what's its derivative? This derives to that. Do you see the chain rule? It's 4 cubed, right? And the derivative of the t is just 1, so it doesn't change it. And then this derives to that. So it does exactly what we want it to do, which is great. All right, so now this is, open parentheses, 50 plus t to the 4th times q prime, and that's equal to 40 times 50 plus t to the 4th integrate, 50 plus t to the fourth times q, because the integral cancels with the derivative, is equal to, all right, this thing, I got to integrate it. Nice that this t has a coefficient of 1, because that means I don't got to worry too much about chain rule. It is going to be 40 over something, open my parentheses, 50 plus t, close, to the fifth. Well, this 40 here needs to get divided by that 5. That's like the basic way to do u sub without doing u sub. You could do this with u's, but as you can see, this problem's kind of long. Oh, don't forget our plus c. Oh, so now here's a good time to solve for the c. We talked about this in the last video. Q of 0 is 50, right? That was the amount of the grams in this thing to start. So Q of 0 is 50. So this is T. It's not good, T. And this is Q. So those guys are 0, and then this is 50. That's nice because I get 50. Well, I don't even want the parentheses. I'll write it. 50 to the fourth times the q is 50 equals, all right, 40 over 5, is that 8? Open parentheses, 50 to the fifth plus c. Now, you could, like, do 50 to the fourth and do 50 to the fifth, and, like, you know, we could use a calculator. But look, this here is a 50. Pop it in there. I have 50 to the fifth. And here, I got equals 8 times 50 to the fifth plus a constant. So c is going to be equal to 50 to the fifth minus 8 times 50 to the fifth. A little inconsistent with my parentheses. But that, well, I got one of these messes minus 8 of these messes. So that gives me -7 of the messes. So that's my c value. So I can now use that here. So I get 50 plus t to the fourth times q is equal to 8 times 50 plus t to the fifth plus, minus 7 times 50 to the fifth. Oh, this is, what is it with, I actually did it. This comes out to be 2 point, if you were to plug it into your calculator, 1875 times 10 to the ninth. So is that 10,000, maybe 10 million? Right? No, 10 billion. Sorry, not 10. This is about 2 billion right here, right? So what is it? It's a big number, right? Let's just write it like this. I would take either one. I would take this times 10 to the ninth. I would take this thing, which that's actually the form that I like the most. Or I would take this with a whole bunch of zeros. Whatever you want to do, it's good with me. I don't really care. And you can use a calculator. That's fine. Okay, so we now, what do we need to do? I want to solve for this q right here. So what am I going to do? I'm going to divide everything by 50 plus t to the fourth, 50 plus t to the fourth, like that. This cancels. Look at this. This is great. There's 4 of them down here, 5 of them up there. This will cancel with all but that and leave me with only 1. And then this guy's not going to change. So I get q of t is 8 times 50 plus t, which if you wanted to distribute that in, that's totally fine. Up to you. That's cool. Minus 7 times 50 to the fifth over 50 plus t to the fourth. Boom. I got my q. Boom. All right, now, so that's my answer to question 1. Next one, what is the concentration of the solution when the volume is 150? So I'm going to pause for a moment and move some things down. So I moved the original picture down, and I moved the question down. The one thing that I want to go to is I need to know when is the concentration of the volume, when is the concentration of the solution when the volume, I'm checking, what is the concentration of the solution when the volume is 150 liters? Well, look, I know that I need to use Q to get to the concentration. So I know that what's my input for Q? It's T. So really, I need to know when is the volume 150. Well, if I go up to the very top of this problem, right there, volume is 50 plus T. So V is 50 plus T. So what time is going to give me V equal to 150? That means T is 100. You could also like logic your way through that, right? We know from earlier that the volume increases by 1 liter every minute, right? It starts with 50. How long is it going to take to get to 150? Well, 100 minutes. So from here, what I need to do is find Q of this value right here. So Q of 100 is equal to, all right, 8 times, here I'm going to get 50 plus 100, so that's 150, minus 7 times 50 to the 5th all over 150 to the 4th. So there, you should plug that into a calculator. That's the way you're going to get that. If you plug that into a calculator, you get 119.679. Now, some people will stop here and be like, oh, I got it. That's my answer. Well, there's a couple problems here. One, I asked for the concentration. What are the units of Q? Remember, the units of Q are grams. Concentration, well, that's grams per liter, right? So it's not the right units, so it's not concentration. 2, if you think about it, and this is what I was trying to say earlier, think about these problems, right? I got 8 grams per liter coming in. I started with 1 gram per liter. I couldn't get up to almost 1,200 grams, right? Or grams per. I couldn't get up to a concentration of almost 1,200. So I need to think. I shouldn't go over a concentration of 8 if I started at 1. So how do I get to concentration from here? Well, concentration is amount over the volume, which is going to be the 1,195.679 divided by, what's the volume? Well, that's my 150 divided by 150. This is grams, this is liters. If you do that, we get 7.971. And that's actually really good. Oh, sorry, grams per liter. Yeah, I'll go like that. Why is that really good? Well, think about it. This thing's been flowing for 100 minutes, right? It's been mixing and flowing, started at 1, but we've been pushing this thing in that's 8 grams per liter. So it's been going for long enough that we are almost at that 8 grams per liter. We're now at 7.971. If I were to let it go further, it would get closer and closer and closer to that 8. If I asked you for what's the concentration when I have 52 liters, not 150, then it would be a lot closer to that 1. So with these context problems, you can really look at your answer at the end and think your way through it and see if you might be right. So that's all. Hopefully you feel like moderately okay after going through 2 of these problems, and we will practice some more. Thanks. Bye.